Welcome to all. In this session we will study remainder theorem and factor theorem. That is when we will go to our higher classes, that is in engineering or in science classes. You can see that a complex situation or a complex problem is usually represented in form of algebraic expression, mathematical expression, sometimes it may be polynomial. In order to evaluate that polynomial, we have to factorize it. Factorization means split the given expression into simpler term and then we will multiply it. Then the evaluation can be made easy. This one, remainder theorem and factor theorem are the stepping stone how to factorize a polynomial. That is, it will give the basic knowledge about this one, factorization. Okay. So before we go to this one, remainder theorem, I will briefly describe what is meant by a remainder. That's you have studied in the earlier classes. The remainder. That is in case of natural numbers. When we divide one natural number with another natural number, we will get a remainder. Is it? Yes, for example, I will take two numbers, two natural numbers. 17 and divide 17 by 5. What will happen? When we divide 17 by 5, how many times? 3 times, then 15, and the remainder 2. This is the remainder. Is it in case of natural numbers? How can we write it as? This one, 17, it is called the dividend, that is equal to divisor, that is 5, into, what is the quotient here? That it is 3. Plus, what's the remainder here? The relation is dividend is equal to divisor into quotient plus remainder. Is it up? You have studied this one in earlier classes to check the test of divisibility. Sorry for the disturbances outside, there is a lot of disturbances today. So we will try our best to reduce that noise. Okay. This is the relation. Dividend is equal to divisor into quotient plus remainder. When this remainder turns to 0, becomes 0, what we call this divisor is called the factor of given number. For example, instead of 17, if you take 15 and 5, what will you get when we divide 15 by 5? What's that? 0. So when the remainder turns 0, we call this one 5 is called the factor of 15. That's the divisor is called the factor of given number. That's the dividend. One more thing. The remainder, the value of the remainder is always less than the divisor. All these things you will study as a lemma, a small theorem in the 10th standard. It's called Euclid's division lemma, and this lemma is used to find HCF two numbers, highest common factor of two numbers based on an algorithm. That algorithm is also called Euclid's division algorithm. The same thing, no? Nothing is more and nothing is less, the same thing. Okay. So you don't forget this one. Relation, and we have studied these things in case of natural numbers in the earlier classes. Here our concentration is about polynomial. Is it? So, based on the polynomial, how can we get the remainder when we divide one polynomial with another polynomial? Okay. That is equal to x square plus 2x plus 1. How many terms are there? There is 3 terms are there. Coefficient of x square is 1 and coefficient of x is 2. And 1 is called the constant term. And dx is the name given to this polynomial. X here represents the variable. That is, don't misunderstand that you must always use this letter x. By convention, I use x. You can use y. These are whatever. Then, our aim is to find the value of this polynomial for a particular value. The variable, that's for x is equal to 1. That is, value of px at x is equal to 1. What you will do? We have to replace all the variable x with 1. That's p1 is equal to. This thing we will also study in higher classes in function. Okay, that's the value of the polynomial at x is equal to 1. What's the value of this polynomial at x is equal to 0? Then what we have to do? We will replace x with 0. Then 0, 0. Then what's the value here? 1. The simple concept. That's the value of a polynomial at a particular value. The next concept, 0 of the polynomial. 0 of the polynomial means the value of a variable which this polynomial turns into 0. That this polynomial becomes 0. Let's call the 0 of the polynomial. So consider a polynomial px or py is equal to y minus 1. This is a linear polynomial. That's polynomial with the degree 1, maximum number of terms 2, minimum is 1. Py is equal to y minus 1. For what value of y this polynomial becomes 0? Yes, 1 plus 1. When y is equal to plus 1, this polynomial becomes 0. Then this plus 1 is called the 0 of the polynomial. Plus 1 is called 0 of py. This is not a polynomial equation. This is here represent py. We can use either py or y minus 1. That is 0 of the polynomial is obtained by equating this polynomial to 0. How do we get this one 0 of this polynomial? We equate this polynomial, that is y minus 1, we equate it to 0. While we equate it to 0 and we do the arithmetic, we will get y is equal to 1. Then this is called the 0 of this polynomial. Then py is equal to 0. What does this represent? This is a polynomial equation. y1 is equal to 0. Polynomial equation. When we solve this polynomial equation, we will get y is equal to plus 1. So in related to a polynomial equation, the value of the variable for which that equation is satisfied is called the root of the polynomial equation. In case of equation, the value of the variable for which equation turns to 0 is called the root. For polynomial, it is called the 0, the same concept. But for polynomial, it is called the 0. For polynomial equation, it is called the root. Okay, never misunderstand these two terms. We never say that root of a polynomial. Root of a polynomial equation. We never say that 0 of a polynomial equation. In case of polynomial equation, we must say root of a polynomial equation. Same concept. So, this is the second concept. Okay. Yes, that is 0 of the polynomial is obtained by equating the polynomial to 0. Then it turns to polynomial equation. By equating to 0, we will get the value of the variable for which the polynomial turns to 0, becomes 0. So for a polynomial, we say that 0 of the polynomial. For polynomial equation, we must say root of the polynomial equation. Py is equal to 0. Whether it is a polynomial or polynomial equation. This is a polynomial equation. This is a polynomial equation. That is, py means y minus 1. Y minus 1 is equal to 0. This is a polynomial equation. Okay. So, Consider, for example, py is equal to 3y plus 3. What is this? Zero of this polynomial? Yes, y is equal to minus 3. So y is equal to minus 3 is called the zero of the polynomial. Then y plus 3 is equal to 0. This is a polynomial equation. This is the root of this polynomial equation is same, minus 3. That is, for equation it is root, for a polynomial it is 0. So what's the general form of a linear polynomial is ax plus b, condition a is not equal to 0. What is the 0 of this equation? We will equate it to 0, then x is equal to minus b by a. Okay. How many zeros are there? Only one zero. For a linear polynomial, there is only one zero. Okay. So you must understand these two concepts. Then, next we will look how can we divide one polynomial with another polynomial. Then only we will get the remainder. Otherwise, we will not get the remainder. Okay. How can we divide one polynomial with another polynomial? In this session, we will study only about the division by a linear polynomial. That is polynomial with only one degree. Here we have to firstly find polynomial in standard form, that is in the descending degree with the higher degree first. Then the degree will be lowered successive terms. So px can be also written as, how can we write it as x square plus 3x plus 3. This is the first step. So divide px by dx, that is x square plus 3x plus 3 divided by x plus 1. Similarly, sometimes gx, the second polynomial may be given in the form 1 plus x. Then we have to write it in standard form. That is the first step. Then what we have to do is take the first term of this dividend. Dividend is this one. And the first term of the divisor. Divide first term of the dividend with the first term of the dividend with the first term of the divisor. This x. So this x is the first term of the quotient. First term of the quotient. Then multiply this term with every term of the divisor. That is x square plus x. Do the subtraction. What is the answer? X square will cancel. And the remainder become the new dividend. Again, do the same procedure. Take the first term of the dividend and the divisor. Do the division. That is 2x by x. What's the answer? 2. This is the symbol is plus. Plus 2. So this is the second term of the quotient. Do the multiplication with this term. Multiply this 2, only this 2 with every term of the divisor. That is 2x plus 2 this term 2 into x, 2x, 2. Do the subtraction. These 2 will get cancelled and the answer is 1. This 1 is the remainder. That is why we divide 3x square plus 3x plus 3 by x plus 1. We will get the quotient as x plus 2 and the remainder as 1. Okay. So we can write it as standard form. That is, you have studied in the case of natural numbers, that is dividend is equal to divisor into quotient plus remainder. So 3x, x square plus 3x plus 3 can be written as x plus 1 into x plus 2 plus 1. Is it right? X plus 2. This is dividend divisor into x plus 2, that is the quotient, plus y, it is the remainder. Am I right? The same relationship we can also apply to this one polynomial. So, where in case of natural numbers we use numbers, here we use polynomial. So, dividend, what is the dividend here? That is px. I will write it here, px, while we divide px with another polynomial, gx. We will get a quotient, qx, and a remainder. Here it is 1. Why we will get 1? It's a constant polynomial. Yes, I have already told you that the remainder is always less than the divisor. In case of natural numbers, here the degree of the remainder is always less than the degree of the divisor. Here the divisor is a linear polynomial, that is degree is 1. So the remainder, the polynomial, the degree of the remainder polynomial is always less than the degree of the divisor polynomial. Divisor polynomial has the degree 1. So the remainder polynomial has the degree less than 1, that is 0, that is a constant polynomial. When the degree is 0, it is called constant polynomial. That's why it is 1. So we never forget this relation. This is the Euclid's division lemma extended to